Hi friends, today we are talking about relation between toughness and resilience. What is toughness and resilience, and also derived some formula with regarding to toughness. So what is a toughness? Toughness is the modulus of toughness is the amount of strain energy per unit volume, or you can say area under the stress strain curve up to the fracture point. This point is noted. Up to the fracture point, area under the curve is known as toughness. Resilience, the modulus of resilience is the amount of stress strain curve per unit volume, or you can say that area under the stress strain curve up to the elastic limit. You note in mind, up to the elastic limit, area under the curve is known as resilience, and up to the fracture point, area is cover under the stress strain curve is toughness. So what is this? We explain with graph. So this is a stress. Y-axis shows as stress and x-axis shows strain. So this curve is valid for ductile material, and here this is a fracture point for ductile material, and here the fracture point FB for brittle material, because this is a fracture point for brittle material. So friends, what this graph is showing now, area under the curve, stress strain curve up to the fracture point is known as toughness. So this is a fracture point for ductile material. If you take this area, then this area is known as toughness. This total area known as up to the fracture point is known as toughness for ductile material. But in brittle material, this area, this fracture point, this area is known as, this point, you clarify, this is known as, also known as toughness for brittle material, and this area is known as toughness for ductile material. And what is the resilience? Resilience, friends, up to the elastic limit, area under the stress strain curve up to the elastic limits. So this is the elastic limit and this is the yield point. So up to the elastic limit means this area under the stress strain curve is known as resilience. This known as resilience up to the elastic limit. So this is a difference between them. So friend, this is a toughness equals to integration 0 to true strain at fracture point. Epsilon F equals to true strain at fracture point. Sigma stress multiplied T epsilon. So this is a formula of toughness. Toughness is equals to this. So friends, you can say that toughness is the energy per unit volume or specific energy that has been dissipated up to the point of fracture. Up to the point of fracture, dissipated specific energy. Friend, this is note that this specific energy pertains only to the volume of material at the narrowest region. Volume of material as the narrowest region. Okay, this is the narrowest region. So narrowest region, or you can say necking point. This is the narrowest region or necking point. So friend, any volume of material away from the neck has undergone lower strain and hence has dissipated less energy than that in the fracture zone. It means this necking region having more dissipated energy as compared to this other zone.